Okay, let's unpack this. Today, we're doing a deep dive into, well, something a bit different. It's the kind of material that powers the unseen gears of industry specifically. An owner's manual for something called a T8-SS modular screen printer.
Yeah, and what's fascinating here, I think, is that even a technical manual, when you really dig into it, can unlock surprising nuggets of knowledge and insight.
Right.
So, our mission today is basically to turn what might seem like a pretty dry set of instructions into a shortcut for you, the listener, to get well informed about a complex piece of equipment fast.
Exactly. Imagine you just got this T8-SS, this modular screen printer, delivered. You need to grasp the essentials now. We're kind of custom tailoring this deep dive just for that scenario. We'll guide you through it like you're setting it up for the very first time. So let's start right at the beginning, getting this machine out of the box and ready to go. And the good news, straight from the manual, is that the T8-SS usually arrives mostly assembled.
Which is definitely a relief, yeah.
So thankfully, you probably won't be spending hours putting basic pieces together.
Right, but mostly assembled still means a few critical initial steps. First off, always, always give the machine a thorough look over for any shipping damage as you unbox it. You never know.
Good point.
Then you'll need to remove a few bolts from the bottom of each leg flange. That lets you lift the main unit off its wooden pallet
Okay.
for stability. Or if you want to move it around easily, you attach the four casters you'll find on that pallet. Or if they sent them, you screw in the rubber leveling pads instead.
Right, casters or pads.
And here's a key detail for stability, especially with the pads. Don't fully tighten the lock nuts on those leveling pads right away. Wait until the machine is in its final spot.
Ah, okay. Why is that?
That's how you eliminate any potential wobbling. Get it perfectly level first, then lock it down. Also, keep an eye out for any detached accessories. Sometimes optional parts get strapped near the legs for shipping.
Makes sense. Okay, so once it's physically in place, stable, level,
Yeah.
the real dialogue with the machine begins. And that starts with its specific environmental needs. Air and electrical connections.
Yep.
And this is where it gets really interesting because the requirements aren't always what you'd maybe expect.
You're absolutely right. The air supply is particularly crucial and, yeah, a bit counterintuitive for some setups. The T8SS demands an unlubricated air source.
Unlubricated.
Unlubricated, leading into its primary filter element specifically. The reason. Certain internal components can actually be damaged by the presence of oil from an external airline lubricator.
Wow. Okay, so no oil.
Right. Now, the machine does have its own built-in lubricator and filter assembly. That system correctly oils the specific parts that do need it. So if your shop's main air system already adds lubricant to the air,
Which many do, right?
exactly, then you'll need to install what's called a coalescing filter on the line going to the T8SS. Think of it as like a superfine oil trap. It strips out those microscopic oil droplets before they reach the machine.
Got it. Coalescing filter.
Before you connect anything, though, fill the machine's own lubricator bowl with the sample oil that came with it. And here's a vital warning. Never use synthetic-based oils or anything containing phosphate esters or chlorinated hydrocarbons.
Okay, why not those specifically?
They're not just bad for it, they will chemically attack certain plastic or composite parts inside this machine.
Yeah.
It could lead to, well, catastrophic failure down the road.
Yikes. Okay, stick to the recommended stuff.
Definitely. And safety first. Always, always disconnect the air supply before you refill that lubricator or change the filter element. Pressure release is key.
Right.
One more thing on air. If you have optional conveyors or other air-powered accessories attached, they each need their own separate air supply line, complete with their own independent filter, lubricator, and maybe regulator. Maintain those just like the main one.
Makes sense. Separate systems.
And for the main connection, you'll find a standard brass hose end, probably 18 or 14-inch pipe thread. Using a quick connect coupling is a smart move. Makes disconnecting for maintenance way easier.
Okay, so that's air, unlubricated in, specific oil in the machine, no weird synthetics, safety disconnects, separate lines for options. Got it. What about the electrical side? Any similar hidden traps?
Fortunately, the electrical setup is generally more straightforward, but still just as critical for safety. You connect the main power supply to a 208-volt single-phase disconnect box.
Okay, 200-208V single phase.
The absolute non-negotiable safety rule, though, before you throw that switch, make sure the door to the electrical enclosure, the power supply box, is completely closed and secured.
Right. Don't want any surprises there.
Exactly. There's really only one key exception to that voltage requirement if your specific T8-SS model is equipped with a 6-inch LED curing module.
Ah, an option.
Right. In that specific case, the machine actually runs on standard 120 volts instead, so double check your configuration.
Good to know. Check for that LED module. Okay, machine's in place, air's hooked up correctly, power's connected safely. Now, let's dive into mastering its controls. The manual notes, interestingly, that while most are grouped on the control box, some are found elsewhere because of the compressed air.
Yeah, that's right. Most are central, but pneumatic controls are sometimes placed closer to the action. So let's walk through the main ones. First, you've got the main power switch, usually a big red knob. That turns the entire system on or off, dead stop.
Okay, the main kill switch.
Then you have your control on-off switches. The green control on button usually illuminates. Pressing it homes, the machine sends everything back to its starting position and gets it ready for operation. The red control off disengages the control circuits.
Green for go, red for stop. Simple enough.
Pretty much. Next, the UV lamp on-off, often a black selector switch. This one's crucial for operation. You must turn the switch to the on position before you actually start running parts through the machine.
Okay, why is that? Warm up.
Exactly. It needs warm-up time, could be 30 seconds, could be a few minutes. You'll know it's ready when its cooling fan kicks on. That signals it's reached the optimal operating temperature for curing the ink.
Ah, listen for the fan.
Right. And just as important, when you're done printing, the lamp must be turned off first. Give it ample time to cool down before you power down the whole machine. The fan will usually shut off automatically when it's safe. Don't rush the cool down.
Got it. Patience required for the lamp, both starting and stopping. What about the different ways the machine can actually run its cycles, like one print at a time versus continuous?
Right, that's handled by the single auto switch, typically another two-position black selector. In the single cycle position, usually on the left, the machine cycles only when you give it a signal. Most often, that's pressing a foot pedal.
Okay, manual control.
Yeah, and the manual actually offers some good practical advice here. It suggests returning the machine to this single cycle mode after any period of automatic cycling before you hit that red control off button.
Why is that?
It's a simple preventative measure. It stops the machine from unexpectedly starting a cycle the very next time you power it on and hit control on. Especially if you have, like, slow start devices attached, it avoids a jolt.
Safety and predictability. Makes sense. And the other mode?
That's auto cycle mode, usually the right position.
Mm-hmm.
In this setting, the machine just cycles continuously. No need for operator input for each cycle. This is great for higher volume runs where you're just focused on loading and unloading parts.
So you just load, unload, load, unload.
Pretty much.
Mm-hmm.
To stop it when it's in auto, you just flip the selector back to single cycle. It'll finish the cycle it's currently on, and then it'll stop.
Okay. And I think you mentioned an optional switch too, print flood.
Ah, yes, the optional print flood and flood print switch. If your machine has it, it changes the sequence slightly. Print flood means the screen starts already flooded with ink, it makes the print stroke, and then the flood bar comes back to reflood the screen for the next cycle.
Yep.
Flood print is the opposite. The screen floods with ink during the indexing motion, then it prints, then resets. Just different ways to manage the ink depending on the job.
Gotcha. And the foot pedal?
The foot pedal is straightforward. In single mode, you tap it for each print cycle. If you hold it down in single mode, it basically simulates auto cycle. In actual auto mode, though, you just tap it once to start the continuous operation.
Okay, that covers starting, stopping, cycling.
Yeah.
But this raises an important point. There's usually a big red emergency stop button, right? Often on the far end of the machine. What is that really for? What's the biggest mistake people make with it?
That e-stop button is absolutely vital to understand correctly. It's usually a large red palm button, the kind that latches when you press it. Its primary function is immediate safety. It instantly depressurizes the entire pneumatic system.
Depressurizes everything.
Everything. Halts all cylinder motion instantly, no matter where the machine is in its cycle, what direction things were moving, anything. It's really there to give the operator a way to quickly stop everything in an emergency situation, maybe to escape entanglement or prevent a crash.
So it's a true emergency stop.
Exactly. And the biggest misconception, as you hinted, is thinking of it as a reset button. It is not a reset button.
Right. What happens if you use it like one?
If you hit it mid-cycle, stopping everything, and then you simply release it, the machine will just continue the cycle right from where it was interrupted.
Oh, wow. Okay.
So it's critical to remember. If you've pressed the e-stop, you still need to keep clear of all moving parts when you release it because it might immediately start moving again. To release it, usually turn the button clockwise and it pops back out.
That's a crucial distinction. E-stop halts, but doesn't reset the cycle position. Good to know. Are there other controls we should be aware of?
Yeah, just briefly, remember there are also pneumatic flow control valves. These are often little knobs or screws located elsewhere on the machine, near the cylinders usually. They allow you to fine-tune the speed of specific movements by controlling the airflow, like adjusting your print stroke speed or flood bar speed.
Okay, speed adjustments, got it.
Right.
Now that we understand how to power it up, control it, stop it safely, let's talk about the real art, the setup. The manual presents it as a logical progression, which sounds helpful, designed to minimize fiddling around later.
It really is about precision and doing things in the right order. You start with what the manual calls a preliminary examination, checking things that, yeah, are often set at the factory but are absolutely crucial to confirm or adjust if needed.
Okay, what's first on the checklist?
First, screen clearance. You need to visually check that the bottom of the screen frame holders, the clamps holding your screen, are positioned higher than the highest point of your arbors.
The arbors being the things that hold the part being printed.
Exactly. Those rotating mandrels or shafts holding your bottles, tubes, pens, whatever. If the screen holders are too low, the arbors could literally rip the screen mesh as they rotate underneath. Very bad.
Right. Avoid screen ripping. Check one.
Check one. Next, taper compensation. Put a sample of the product you're going to print onto an arbor. Now, look closely. Is the top edge of that product parallel to the screen frame holders above it?
Okay, checking for parallel alignment.
Right. This is usually factory set for a standard cylindrical part. But crucially, if you change to different arbors or print on products with a noticeable taper, you will need to readjust this later. The manual points to Section 6C for how to do that.
Good to note. It might need adjustment later. What's next?
Axle alignment. You need to verify that the axis of rotation of the arbors, the imaginary line they spin around, is perfectly perpendicular 90 degrees to the main carriage shafts that the print head moves along.
Okay, perpendicularity check.
Again, typically factory set. You'd only really need to worry about this if maybe the whole indexer unit that holds the arbors got shifted side to side for some reason. Section 6B covers that adjustment if needed.
Got it. Factory settings are good, but nowhere to look if things change.
Exactly. Now, once those fundamental checks are done, you install the squeegee. That's the blade that actually pushes the ink through the screen mesh onto your product.
Right, the squeegee.
You take a clean, sharpened squeegee bar and insert it into the slotted holder. There's usually a quick release pin to secure it. You might need to loosen the tilt adjustment screws mentioned in Section 7D and E just a bit to get the bar seated properly.
Okay, clean squeegee in, secured.
Then, squeegee alignment. You need to ensure the squeegee blade itself is parallel with what the manual calls the print head bridge, basically, the main structure holding it. For cylindrical printing, this is critical. The length of the squeegee must be exactly parallel with the arbor's axis of rotation.
Parallel to the spin.
Precisely. Think of it like a razor blade needing to skim perfectly along the surface of that spinning bottle or tube. This is different from printing flat objects where you might angle the squeegee slightly, like a snowplow.
Okay, parallel for cylinders. And the last preliminary check.
Over-center adjustment. This is about the squeegee blade's position relative to the very top of the part being printed. The tip of the blade should be exactly over the highest point, the 12 o'clock position, or maybe just a tiny bit, like 1 millimeter to the left of center as you face the machine.
Just slightly off-center to the left or dead center.
Right, and here's a crucial little step related to that. Make absolutely sure your rotary dial plate, the part that indexes or rotates your product into the print position, isn't partially indexed between stations.
Make sure it's fully clicked into place.
Exactly. Manually rotate it counterclockwise until it hits its hard stop. That confirms the arbor you're checking is truly in its topmost 12 o'clock position before you make that over-center judgment.
Got it. Confirm position before adjusting. Okay, preliminary's done. Squeegee's in. Now loading the actual screen.
Right. And before you touch the screen, double check. The red control off button should still be engaged. Safety first.
Control off. Check.
Then you'll likely need to raise the carriage, the whole print head assembly, to give yourself room. Now, position the left end of your screen frame under the clamp screws of the rear screen frame holder. Get it straight? and tighten those screws securely.
Okay, one end secured.
Make sure both your squeegee and your flood bar, the bar that spreads the ink, are in their uppermost positions. You can usually turn their downward limit adjustment knobs fully counterclockwise to ensure this.
Squeegee and flood bar up high.
Yep. Then, position and tighten the opposite end, the front end of the screen, under the clamp screws of the front screen frame holder. You can also adjust the squeegee's maximum upward travel limit at this stage if needed, usually by loosening a screw and sliding a stop block along the cylinder rod that lifts it.
Okay, screen loaded and secured. Now let's talk about a term I know is critical in screen printing.
Yeah.
Off contact. What exactly is it, and how do we set it on this machine?
Right. Off contact is fundamental. It's basically the small gap you intentionally create between the bottom of your stretched screen mesh and the surface of the product you're printing on, specifically at the point where the squeegee will make contact.
Okay, a deliberate gap. Why?
It allows the screen mesh to snap cleanly off the substrate right after the squeegee passes. This sharp release is crucial for getting a crisp, well-defined print edge and preventing ink smudging or blurring.
Ah, the snap off. Makes sense. How do we set it here?
So, you place a sample product on the arbor that's currently at the top, the 12 o'clock position. Then, you lower the carriage assembly. Next, you loosen the locking levers for the vertical adjustment, and you turn the hand wheels, there are usually two, to lower the screen until you get an approximate gap of 1/116th of an inch. That's about 1.5 millimeters.
Okay, 116th inch gap using the hand wheels.
Right. Now, here's where it gets really interesting. A key practical step mentioned in the manual. The next thing you do is raise the front carriage support vertically by about 14 inch or 6 millimeters.
Raise the front. So you're tilting the whole carriage up slightly at the front.
Exactly. And the manual explains why this is so important. It helps to remove the full dead weight and, maybe more importantly, the operational vibration of the carriage assembly from bearing down directly on the overhead cylinder mechanism during the print stroke. It leads to smoother operation and potentially longer life for those components.
Huh. That's a clever mechanical detail. So lifting the front improves performance and longevity.
It seems so. And the result of lifting that front edge is that your final off-contact distance will naturally increase to about 3/116ths of an inch, roughly 4.7 millimeters. That slightly larger gap, achieved by tilting the front up, is considered the optimal setup for that clean snap-off we talked about.
Okay, so set to 116th, then lift the front 14 inch, resulting in about 316th actual off contact. Got it. Now, with the screen loaded and the gap set, how do we tell the machine where to start and stop printing along the product? Defining the boundaries.
Right, the print stroke itself, that's controlled by the print and flood stroke limit bars. These are typically two black aluminum bars, each equipped with a shock absorber, and they're clamped onto the main horizontal carriage shafts that the print head slides on.
Okay, adjustable bars with shock absorbers.
Exactly. To set the flood stroke limit, that's the rear bar, on the left, as you face the machine, you loosen its clamp and slide it into position. The critical detail here is placement. You need to make sure your screen image area will move completely past the flood bar during the flood stroke.
Why completely past it?
Because, as the manual warns, ink tends to slowly bleed or weak through the open mesh of the screen. If the flood bar sits idle directly over part of your image area between cycles, you can get unwanted ink marks or buildup right under it.
Ah, ink bleed. Got it. Move the image fully past the idle flood bar.
Precisely. Now, for the print stroke limit, that's the front bar, on the right, you adjust its position similarly. You want to set it so the screen image moves about, say, 12 inch or maybe 12 millimeters beyond the squeegee blade at the end of the print stroke.
Half inch past the squeegee.
Yeah. That ensures the squeegee completes its work fully across the entire image area, giving you a complete, clean print from edge to edge.
All right, that setup sounds meticulously precise. Screen clearance, taper, alignment, off contact, stroke limits. Now for the moment of truth, right? Test prints. And how to troubleshoot when things inevitably aren't quite perfect yet. What are we looking for, and what are the first adjustments?
This is where the fine-tuning really happens, yeah. First, you'll adjust the squeegee and flood bar depth or downward travel limits. For the flood bar, you use its adjustment knob, usually knurled. You want its lowest position to be as close as possible to the screen mesh without actually touching it, just kissing distance.
Flood bar close, but no touch.
Right. For the squeegee, it's a bit more specific. You turn its knurled adjustment knob counterclockwise to raise it to its maximum height first. Then manually push the squeegee holder down until the blade just touches your sample product on the arbor. Now, turn the knob clockwise until it just contacts the stop collar that limits its downward travel. And then here's the specific instruction. Continue turning it clockwise one full turn beyond that initial contact point.
One full turn past the stop.
Okay, that sets the pressure, presumably.
Exactly. It sets a baseline pressure. Now, what's truly fascinating here, especially for long-term operation, is something the manual points out about UV inks.
Oh yeah, what about them?
UV inks, or maybe the solvents used with them, can actually cause the rubber or polyurethane squeegee blades themselves to swell slightly over time,
Yeah.
or with prolonged use.
Swell, so the blade gets physically bigger.
Yeah, subtly. But enough that it can change that crucial pressure adjustment you just made.
Yeah.
So the manual offers this really clever, practical workaround.
What's the trick? It recommends keeping 2 complete squeegees, already mounted in their holders, on hand. Then you alternate them daily. Use one today, let it rest and recover tomorrow while you use the other one. This simple rotation helps prevent that swelling condition from becoming a persistent problem.
That is clever. A simple solution for a subtle material science issue. Rotate your squeegees daily with UV inks. Excellent tip. Okay, depths adjusted, squeegees potentially rotated. What do we look for during the actual test prints, and how do we fix common stuff like, say, voids or gaps in the print?
Right, so first load up your arbors with blank products. Carefully pour your ink onto the screen, making sure to avoid getting it on the main carriage shafts. Then cycle the machine a few times, maybe in single cycle mode, just to prime the screen and get ink flowing. Adjust your print and flit speeds using those flow control valves until you get a smooth, consistent movement.
Okay, primed and running smoothly. Now voids appear. What's step 1?
If you start seeing voids, areas where the ink didn't transfer properly, the first place to check is your flood bar operation. Is the flood stroke correct? Meaning, is the ink being spread evenly and completely covering the entire image area on the screen before the print stroke?
Check the ink coverage from the flood.
Right. If it's not covering completely, you might need to lower the flood bar's downward limit just a tiny bit more, or, often more simply, just add more ink to the screen. Also, if the flood bar seems to be skipping or not pulling a consistent sheet of ink across, the manual suggests you might need to increase the distance between the flood bar and the squeegee slightly.
Okay, adjust flood depth, ink level, or flood bar position relative to squeegee. What if voids still persist?
Then it's time to look critically at the squeegee itself. Observe its path during the print stroke. The squeegee must make firm, consistent physical contact with the substrate through the screen mesh. A telltale sign of insufficient contact or pressure is seeing a thin, maybe uneven layer of ink remaining on the product in the squeegee's path after it passes.
Oh, leftover ink means not enough pressure.
Exactly. If you see that, the fix is to increase the squeegee pressure slightly. You do this by turning that squeegee depth adjustment knob counterclockwise, but only in small, precise increments, like maybe an eighth or a quarter turn at a time. Test again. Little adjustments are key.
Small increments. Got it.
Yeah.
And what if the print quality issue is different? Like maybe the voids are always on one side of the print, or the printed lines look heavier on one side than the other?
That often points to an issue with uneven pressure across the squeegee length. It could be caused by the screen tension being slightly irregular, or it could be related to that product taper we talked about earlier if it wasn't fully compensated for in the setup.
Okay, uneven pressure. How do we fix that?
The machine usually provides a way to tilt the squeegee slightly. There are typically tilt adjustment screws, referenced in Section 7D of the manual, at either end of the squeegee holder. You can use these to apply slightly more pressure to one end of the squeegee blade than the other, compensating for the unevenness.
So you can fine-tune the angle.
Right. But, and this is an important warning from the manual, this tilt adjustment should not be used as a brute force method to make the squeegee conform to an excessive taper on your product, say, more than just a few degrees.
Why not? It seems like it would work.
It might seem like it, but trying to force a straight squeegee down hard onto a steeply tapered surface puts immense stress on the screen mesh right at the edges. It's a recipe for premature screen wear and tear, maybe even ripping.
Ah, okay. Bad for the screen.
Very bad. If the taper is excessive, the manual strongly advises going back and readjusting the indexer's vertical orientation, leaning the whole arbor assembly like we discussed in the changing arbor section. That's the proper way to handle significant taper.
Got it. Use tilt for minor tweaks, indexer orientation for major taper.
Okay.
Assuming we get the print quality looking good, no voids, even lines, how do we nail the final positioning? Aligning the screen image precisely on the product.
Right, the final registration. Once the quality is good, you adjust the imprint's position. Now, if your machine doesn't have a specific rack and pinion screen adjustment system, which some higher-end models might, the manual notes that precise circumferential adjustment, like rotating the image around the bottle minutely, isn't really possible just by moving the screen.
Okay, so what can we adjust easily?
You can definitely adjust the position along the length of your product. You do this by carefully loosening the screen clamps and sliding the entire screen frame laterally, side to side, in the holders until the imprint is where you want it lengthwise.
Slide the screen side to side for length positioning.
Exactly. You can also adjust the screen's angle slightly within the clamps. This is important if you notice the imprint seems to be spiraling slightly along the circumference of the product as it prints.
Spiraling, like a candy cane stripe.
Kind of, yeah. That usually means the lines in your screen image aren't perfectly parallel to the direction of the print stroke. You need to rotate the screen frame just a tiny bit in the clamps until that image is truly parallel to the line of travel. Then retighten everything securely.
Parallelism is key again. Okay, that makes sense. Now, one of the big selling points of a modular machine like this T8-SS is presumably the ability to change those arbors,
Right.
to switch from printing pens to printing bottles, for example.
Mm-hmm.
How does that process work, and what are the critical adjustments you absolutely have to make when you do that?
Yeah, that modularity is a huge advantage for flexibility. The process of actually changing the arbors themselves is usually quite simple. There's typically a black clamp collar with a screw on the end of each arbor station's axle. You just loosen that screw,
Okay.
pull the collar off the axle, slide the old arbor and its bearing assembly off, install the new arbor bearing assembly for your new product, slide the collar back on, and retighten the screw. The key is to make sure there's no end-to-end looseness or slop in the arbor once it's clamped.
Seems easy enough.
Yeah.
Loosen, swap, tighten, check for play. But what about alignment after the swap?
That's where the critical adjustments come in. Because the new arbor might hold the product slightly differently, or the product itself might be a different diameter or shape. First, you need to check and likely adjust the lateral position and alignment of the entire indexer assembly.
The whole rotating magnetic.
Right. You typically place a sample of your new product, maybe one that's already printed correctly from a previous run if you have one, onto the top arbor, the 12 o'clock position. Then you loosen the main mounting bolts that hold the indexer bracket to the machine frame.
Okay, loosen the indexer.
And then you physically slide the entire indexer unit left or right until the imprint area on your sample product is positioned fully under the squeegee's path. You want to avoid the squeegee running off the edge of the print area or the product itself.
Center the print zone under the squeegee.
Exactly. Now, before you retighten those main indexer bolts, you need to re-verify that the top arbor is still perfectly perpendicular to the main carriage shafts. A good way to do this is to use the squeegee blade itself as a reference line, ensuring it's parallel to the arbor's axis like we discussed earlier. You might also align the product's mold line, if it has one, to be parallel with the squeegee. Get that perpendicularity right, then tighten the indexer bolts.
Okay, slide, check perpendicularity, then tighten. What about taper on the new product?
Right, that's the other big one, compensating for taper. If your new product has a noticeable or excessive cylindrical taper again, the manual suggests more than a few degrees, you absolutely need to adjust the indexer's vertical orientation.
This is the leaning adjustment we touched on.
Precisely. The indexer assembly is usually mounted on 4 threaded rods with adjustment nuts above and below the mounting bracket. By carefully adjusting these nuts, you can physically lean the entire indexer body forward or backward.
Okay, using the nuts on the threaded rods.
Yep. And the goal here is to lean it just enough so that the top edge profile of your tapered sample product becomes perfectly parallel to the screen frame holders above it. This ensures the squeegee meets the angled surface consistently along its length, rather than digging in at one end.
Makes perfect sense. Match the indexer, lean to the product taper for even printing. Okay, these adjustments are clearly critical for getting good prints job after job. But what about just keeping the machine itself running smoothly, accurately for the long haul? Let's shift focus to regular maintenance.
Absolutely. Regular maintenance is, well, it's everything for the longevity and consistent performance of any piece of industrial equipment like this.
Yeah.
It prevents unexpected downtime and keeps quality high.
So what are the key routine tasks for the T8-SS?
For the air system, which we established is critical, you need to regularly drain any accumulated liquid, mostly water condensation, from the main air filter bowl. There's usually a little drain plug or valve at the bottom you turn. How often depends on your air quality and humidity.
Drain the filter bowl.
Also, keep an eye on the filter element inside that bowl. When it looks dirty or clogged, you need to clean or replace it. It's always a good idea to keep spare filter elements stocked so you're not caught out.
Clean or replace filter element. Got it.
Then there's the lubricator bowl. You need to maintain the oil level in it, but remember that crucial safety step. Always disconnect the air supply line before you unscrew the oil fill screw or plug to add oil. Never do it under pressure.
Disconnect air before adding oil. Vital.
And reiterate the oil type. Use only proper air tool oil or pneumatic lubricant specified for these systems. No substitutes.
Right.
Oil only. When you first set up the machine or after maintenance, you adjust the lubricator drip rate. The manual suggests aiming for approximately 3 drops of oil per minute when the machine is cycling at full speed. Once you get that rate set correctly, it should generally remain fixed for the life of the machine. You shouldn't need to constantly fiddle with it.
Set the drip rate once. 3 drops per minute at speed.
And here's another really important cleaning warning related to the air system components. Do not use solvents or any solvent-based cleaners to clean any part of the filter bowl, the lubricator bowl, or their internal parts.
Why no solvents?
Because many industrial solvents will chemically attack the polycarbonate plastic that those bowls are usually made of. It can make them brittle, cloudy, or weak, causing them to eventually rupture under air pressure. Very dangerous. Use soap and water or manufacturer-recommended cleaners only.
Huge safety point. No solvents on plastic air parts.
Okay.
What else?
If your machine happens to be equipped with vacuum pumps, maybe for holding parts down, they usually have a small dust filter at the vacuum pump input. You should check that regularly and empty it out. Usually you can just pull the filter housing off, tap out the dust, maybe blow some gentle air through it, or replace the element if it's clogged.
Check vacuum filters if equipped.
Beyond the air and vacuum systems, it's just good general practice to keep all the exposed shafts and rods on the printer clean. Wipe them down regularly to prevent dust and ink buildup, which can cause friction or wear.
Keep shafts clean. Good habit.
And finally, if you ever need to replace any of the pneumatic cylinders themselves, the manual stresses the importance of proper alignment when installing the new one. Before you fully tighten the mounting brackets, make sure the cylinder rod can move smoothly through its entire stroke without any binding or side loading. Poor alignment will kill a new cylinder fast.
Ensure smooth travel for new cylinders.
Yeah.
Got it. That covers a lot of ground on maintenance.
It does. And if we kind of connect all this back to the bigger picture,
Yeah.
what we've journeyed through today isn't just like a random list of instructions from a manual. It's really a blueprint for mastery of this specific machine.
Blueprint for mastery. I like that.
We've seen how precision in literally every single step, from something as seemingly basic as the air supply details, all the way to the exact angle of that squeegee tilt, how all of it profoundly impacts the final printed product.
Yeah, the cumulative effect of all those details.
Exactly. Understanding a manual like this, really delving into the why behind each adjustment, knowing the potential consequences of getting it wrong, it's truly a shortcut, as we said at the start, to being well-informed. It leads to more efficient operation, consistently high-quality output, and hopefully avoiding costly mistakes or downtime.
So wrapping this up, what does this all mean for you listening? In a world that's increasingly driven by automation, by complex machinery, what does this deep dive into the setup, the fine-tuning, the maintenance of just one machine like the T8-SS tell us? Maybe it tells us something about the indispensable blend that's still required between really sophisticated engineering on one hand and attentive, knowledgeable human expertise on the other. Even the smartest machines need a skilled hand and a deep understanding to truly unlock their full potential. It's not just plug and play.
Well said.
Something for you to mull over until our next deep dive.